Alrighty, this is going to be the Cornell Notes Part 2. So you have already done Part 1, and you can see I already have Part 1 in here done in red and blue. So make sure that those are already completed before you're watching this video. And that is labeled Cornell Notes Part 1, so you should be able to do that. So for the first one, and even if we have not gotten to these lessons yet, it's okay. I want to make sure that you all have these filled in before we move forward. So I'm going to make it purple. And oops, I have all my notes here. All right. So when magnets are misaligned, there is both a repelling and attracting force between them. And the reason that is a good way to think about it is if they're kind of like crisscross a little bit, they might be attracting or repelling right here, but then the other sides, depending on how they're misaligned, because remember, opposites attract. And so to be lined up or lined up like this, perfectly on top of each other or touching, that would be aligned. Misaligned would be kind of like a zigzag. And so that is the idea that that formation could cause both to be happening at the same time. And we will investigate that. I'm going to make this bold. All right, the next one that we are going to look at So in 1.6, we're going to look at some claims, and obviously we have not done that yet, but we will. And so here's what you needed to get out of that. So claim 1 is not true because there is no difference in the pattern of field lines for all 3 launchers. So remember, our chapter 1 investigation was how the launcher can make that spacecraft move without touching it. You can see that question right here. And so that's kind of what the claims are based around. Okay. And then since the field lines are all similar and show what is expected for aligned magnets, the launcher must have, must have been aligned on Tuesday. Because remember in our video, we saw that they did 3 different launches and we got a variety of numbers. We were below on Monday and Tuesday, and then Wednesday we overshot it. And so we kind of have to investigate what is going on with that. So, excuse my dog in the background chasing a cat. So I'm just clicking up on these to kind of save some space. Oop, that's not letting me. My computer is going slower than slow. All right. So scrolling down, we see down here that we have a variety of things. And so we used a model multiple times through 1.3 and 1.5, thinking about magnets and how they attract and repel. And so I'm going to change my color. I'm going to go with green. And so the idea, and you can see my investigation question over here, how you can tell whether 2 magnets will attract each other or repel each other or both. And so the idea that you needed to get with the models is magnets act differently and their field lines look different depending on how the poles are situated. And that's kind of the idea I was talking about. If they're on top of each other, if they're side to side, if they're far apart, how strong the magnets are, it kind of depends on what the situation is. And I'm just, going with colors at this point. So we read an article about Earth's geomagnetism. I actually read it to you and helped you kind of highlight the important facts. And so the main ideas that I wanted you to get out of this is that Earth is a big magnet due to the liquid iron in the core. And then down here in 1.5, it wanted you to reread it. And so it's the same article though. So the idea was that magnetic field line models give clues about whether a magnet or magnetic force will cause magnets to attract each other, repel each other, or both. And so that is the idea that you were supposed to get from the reading. And so let's see, I spelled this wrong. Alrighty. And then we have two vocab words over here that I'm going to put in for you. And so we have magnetic field and magnetic field line. If you remember from the article, we looked at these and kind of saw some pictures of them. And those were the lines around the magnets, and the lines that were touching showed they were attracting. Ones that were kind of going around were showing that they were repelling. And so if you kind of forgot about that, you can refer back to that article, which is in this notebook. And so a magnetic field is the space between, or actually, I'm not going to say between, I'm going to say around a magnet. Spell magnet wrong. Magnet in which magnetic forces can act on objects. And then we have magnetic field line. And that is a line that connects opposite magnetic poles and represents the strength and direction of the magnetic field. Alrighty. See if I can save some space here. Alrighty. The last thing is that, for this page, which just made me go to the next page, we in 1.5 use the simulation to explore field lines further. And so, the idea that you needed to get out of that was attracting magnets field lines connect one pole of one magnet to the opposite pole of the other, repelling a magnet's field lines connect one pole of a magnet to the opposite pole of the same magnet. The same idea, just a fancy way of saying the same kind of thing that we've been going with. Opposites attract, like poles repel. I've got to fix all these spelling mistakes that here we go. And then the final thing here, we already put in 2 of our key concepts, so we just need to put in our third. And our third key concept is that the pattern of magnetic field lines around attracting magnets is different from the pattern of magnetic field lines around repelling magnets. You think I could spell this right? I keep doing a typo on that one. All right. And then our chapter question, if you remember, we were thinking about the launcher and how it could launch something without touching it, not something, the spacecraft. And so the launcher made the spacecraft craft move by exerting a magnetic force on it. Magnetic forces can act at a distance to make objects move. In a system of magnets, which means more than one, there is a repelling force, force between like poles and an attracting force between opposite poles. Here we go. So I'm assuming they want that to be one word. Alrighty. So the whole idea is that these magnets are strong enough to act at a distance, and we know like poles repel, opposite poles attract. And that should wrap up the whole first chapter for you.